Good afternoon all. Myself Ashley Elizabeth of S7ECA. Today I am going to take seminar about the topic 6G Technology and Future Communication Network under the guidance of Dr. Arun T. These are the contents that are included in this presentation, which includes introduction, evolution, 6G technology, challenges and its solution, advantages, application, then the 6G architecture, antenna and modulation key schemes, ethical consideration and compatibility issues, global standardization, research perspective, future communication network and scope, conclusion and references. Moving on to the introduction, as we all know, wireless communication plays a major role in our life. In order to meet the futuristic demands of both human beings and machine, it is important to improve the current communication technologies. New technologies such as 6G and other advanced future communication networks are expected to make the mobile devices even more powerful and versatile. And the future of this communication network is dynamic and it has the potential to revolutionize the way we live, work, and communicate. On to the historical evolution. As new technologies continue to emerge offering greater benefit, the evolution of mobile technology has been a remarkable journey from simple communication devices to powerful multifunctional tools. And the various stages of advancement in this wireless communication technology refers to mobile network generations, and these generations are denoted by G. The development roadmap of mobile cellular network. In 1979, 1G, the first generation of mobile cellular network, was introduced in Japan. It is an analog-based technology and used for voice calling only. In 1991, 2G became available. It is the first digital standard and it is used for voice calling and data services such as SMS and MMS. 2.5G and 2.75G are the two intermediate technologies between 2G and 3G. These two technologies provide higher speed data rate compared to 2G but slower compared to 3G. Then in 2001, the third generation of mobile cellular network, that is 3G, became available. It is the first mobile broadband and it uses internet to support email, web browsing and video streaming. 3.5G and 3.75G are the two enhanced technologies of 3G, and these two technology provide a higher speed data rate compared to 3G but slower compared to 4G. In 2009, 4G has been introduced. It is the fourth generation of mobile cellular network and it gives support for more devices on same network. 4G has introduced a new feature, that is LTE, long-term evolution. And in 2019, 5G, the fifth generation of mobile cellular network, became available. It gives support for IoT and has a major impact on mobile industry today. Beyond 5G, that is 6G, is expected to become available in 2030, and it is expected to provide support for augmented reality and virtual reality. The importance of progress in communication technologies. As there is advancement in this communication technology, it offers greater benefits such as coverage area expansion, time management, it is faster and efficient, it simplifies tasks, expanded security, save cost, increased innovation and mass communication. 1G technology. 1G was the first generation of mobile cellular network and it was introduced in Japan by NTT, that is Nippon Telephone and Telegraph Company, in 1979. 1G is an analog technology and it supports voice calling only. The maximum speed of 1G technology is 2.4 kilobits per second and the frequency ranges from 800 megahertz to 900 megahertz and the bandwidth is of 10 megahertz, and the multiple access technique used in 1G is frequency division multiple access. Then the 2G technology. 2G was the second generation of mobile cellular network and it was introduced in Finland. 2G is the first digital standard and it was launched under GSM, that is the Global System for Mobile Communication. The frequency range of 2G is from 900 MHz to 1800 MHz and the bandwidth is of 25 MHz, and it is capable of supporting up to 64 kilobits per second data rate, and the multiple access technique used in 2G is time division and code division multiple access. 2.5G and 2.75G technologies are the two intermediate technologies that bridge the gap between 2G and 3G network. When 2G GSM compared with GPRS, that is the General Packet Radio Service, is called 2.5G. and this leads to 2.75G, which provide the threefold speed increase compared to 2G. And these two technologies are not defined formally as wireless standards. Then the 3G technology. 3G was first introduced in Japan in October 2001 by NTT Docomo. It is support video calling for the first time on mobile devices, and the frequency range of 3G is from 1.6 GHz to 2 GHz, and the bandwidth is of 100 MHz. And 3G plus technologies are HSPA and HSPA plus, that is high speed packet access, and it is capable of supporting up to 2 megabits per second data rate. And 3G technology uses wideband code division multiple access technique. 3.5G and 3.75G are the two enhanced technologies of 3G. 3.5G support up to 14.4 megabits per second data rate, and 3.75G system is an improved version of 3G network with HSPA+. Later this evolved into more powerful 3.9G system. 4G technology. 4G was the fourth generation of mobile cellular network, and it was defined by ITU, that is the International Telecommunication Union. The 4G technology is capable of supporting up to 100 megabits per second data rate, and the frequency range is from 2 to 8 gigahertz, and the bandwidth is of 100 megahertz. And the multiple access technique used is orthogonal frequency division multiple access. And 4G has introduced a new term, that is LTE, long-term evolution, and the improved version of LTE is voice over long-term evolution. 5G technology. 5G is the fifth generation of mobile cellular network, and it delivers ultra-fast internet, that is up to 10 gigabits per second. 5G uses millimeter wave for data transmission, and the sub-6 gigahertz is the most widely deployed 5G network today. That is, frequency range is below 6 gigahertz in the radio spectrum. And the multiple access technique used in 5G is non-orthogonal multiple access. Moving on to the next slide, that is the 6G technology. 6G is the sixth generation of mobile cellular network. It is a promising new technology that will be a broad platform for innovation, and it is incorporating with novel approaches like edge computing, artificial intelligence, and terahertz waves. The 6G technology was still in its early stage of research and development, and is expected to become available in 2030s. Then the challenges of 6G. There are three types of challenges: technological challenges, security challenges, social challenges. Technological challenges. Technological challenges include spectrum utilization. That is, 6G is expected to operate on this terahertz frequency range, and it makes long-range communication difficult, as these terahertz waves can be easily absorbed by atmospheric gases, water vapor, and rain. Then the area expansion challenge. One of the major goals of 6G is to expand the coverage area, and this challenge is significant as 6G is aimed to provide worldwide connectivity. Then the radio wave use expansion challenge. As there are increased demands and capabilities of this 6G network, it is difficult to expand the use of these radio frequencies and the spectrum bands to accommodate these the demands and capabilities of 6G network. Then the second challenge, that is the security and privacy challenges. The privacy protections includes mm, concern about the user privacy that require innovative approaches and robust privacy policies to balance users' privacy along with the data collection. Then the cyber security, as there are higher connectivity and complexity of the 6G network, it can be easily affected by the cyber attacks. The third challenge, that is the social challenges. Regulatory frameworks such as spectrum allocation, licensing, competition policy will be challenging to develop and adapt these regulatory framework for 6G technology. Then the global cooperation, as 6G is expected to provide worldwide connectivity, it is essential to achieve global standards and harmonization in the 6G technology for seamless international communication. And it is more complex challenge to collaborate across borders, negotiating agreements, and addressing geopolitical concerns. Then the carbon free. As there are new technologies continue to emerge offering greater benefits, The sustainability and reducing carbon emission have become an important consideration in this development of this new technology. Uh, Moving on to the solution for these challenges, the solution for technological challenges includes developing new antenna designs using MIMO arrays relay stations to improve the propagation and efficiency of terahertz communication, then using a non-terrestrial network and large number of small cells also improves the terahertz communication, propagation and efficiency. Then the security and privacy challenges, the solutions are developing new AI algorithms that can detect and mitigate the cyber attacks. Then encryption, which is the process of protecting user data using mathematical models. Then the other solutions includes proper authentication and proper authorization. The solution for social challenges are government interventions, ethical guidelines, and to reduce this carbon emission, University of California, Berkeley are developing new type of solar panel that is designed to power the 6G network. Moving on to the advantages of 6G technology. The first one is the ultra high data rate, that is up to 1 terabits per second. Then the ultra low latency less than 1 millisecond, that is about 10 to 100 microsecond. Extended coverage 155 to 175 gigahertz over 320 meter. Then interoperability, it is the ability of different devices or system to work together seamlessly, and 6G is expected to be interoperable with the previous generation. Then the energy efficiency, that is 70% is less highly reliable compared to 5G. Then the other advantages are global connectivity, improved security, and advanced spectrum usage. Then the applications of 6G technology. 6G enables a wide range of innovative applications that includes AR and VR. 6G could enable more realistic augmented reality and virtual reality experience. Self-driving cars and other autonomous vehicles require extra low latency and high bandwidth connectivity for real-time communication. Then telemedicine, 6G could enable advancement in telemedicine applications that includes a real-time patient monitoring and the use of medical wearables. And as there is enhanced connectivity made possible by 6G, it enables more interactive online learning experience. And for the environmental monitoring, 6G can be used to collect and analyze data for environment monitoring, helping to address climate changes and natural disaster. For security and defense, it enables more secure communication network for military and government purposes. And 6G is expected to support massive number of connected devices, which facilitates the growth of smart cities and IoTs. And it is used for precision farming with real-time detection of soil, weather, and crop health. Moving on to the technologies behind 6G. First one is the artificial intelligence. AI is expected to play a major role in 6G network by optimizing network performance to develop new application. Then the terahertz spectrum, as 6G is expected to operate on this terahertz frequency range. It allows for much higher data rate and extra low latency. Then the massive MIMO, that is the multiple input and multiple output, that uses multiple antennas to transmit and receive data simultaneously. And to support the new application that enabled by 6G, edge computing and cloud computing is used. And to improve the performance of 6G network, quantum computing could be used, and blockchain technology can be used for transparent and secure supply chain. Then the 6G architecture. The 6G architecture was still in its early stage of research and development, and it is expected to come with advanced domain automation and functionalities providing orchestrations and automation across multiple network domains. The proposed 6G network architecture is termed as solids, that includes six features. First one is S, which stands for soft, then O for on-demand fulfillment, L for light, I for native intelligence, D for digital twin, and S for native security. So the first feature is soft. 6G should be flexible and soft enough to adapt the changing demands and capabilities. Then the on-demand fulfillment, it should provide resources and services on demand based on the needs of user and application. The third feature is light. 6G should be lightweight and efficient, using resources sparingly to reduce cost and power consumption. Then 6G should be natively intelligent, using AI and machine learning to automate tasks and improve performance. Then the next feature is the digital twin. It is a real-time virtual representation of a physical network that can be used for monitoring, simulation, and optimization. Uh, then the native security. 6G should have security built in from the ground up, using AI and machine learning to detect and respond to threats. And this architecture will be flexible and highly specialized to used in large scale wide area network. Then the antennas used for 6G. General antenna specification for 6G communication system are millimeter wave antenna, that is potentially above 100 GHz, that provide high data rate and extra low latency. Then the massive MIMO, that is the multiple input multiple output antennas, that uses large number of antennas to improve the spectral efficiency and increase network capacity. And terahertz antennas plays a major role in 6G, which provide higher frequencies than millimeter wave frequency. Then the UWB antennas, that is the ultra wideband antennas, that enable extremely high data rate and extra low latency by utilizing a broad spectrum of frequency. Then the circular polarization antennas, it covers the range of frequency band of sub-terahertz and terahertz in the electromagnetic wave spectrum. Moving on to the modulation schemes used in 6G. First one is the index modulation. It is a promising sixth generation technique that improve the spectral efficiency, energy efficiency, system performance, and support massive connectivity. Then the non-orthogonal multiplexers. It is a modulation technique that allow multiple users to share the spectrum resources, that includes frequency and time. Then the RIS-based modulation, that is the reconfigurable intelligent surface. It is a promising modulation schemes that meet the demanding requirement of 6G technology. Then the OTFS, that is orthogonal time, frequency, and space, which has a number of advantages that make it attractive for 6G technology, like reduced latency and high spectral efficiency. Then the ethical consideration. To shape the responsible development and deployment of 6G, it is essential for stakeholders such as researchers, policymakers, and industrial leaders to engage in these ongoing ethical discussions, that includes ethical AI and automation, data ownership and control, privacy concerns, global governance, accountability and transparency, open standards, and interoperability. Then the compatibility issues of 6G technology. It is cost prohibitive to upgrade these 5G devices to support 6G feature. So backward compatibility is essential for 6G technology. As 6G was still in its early stage of development, it is possible to identify these compatibility issues and resolve before these technologies widely deployed. Then the global standardization body. Several standardization bodies are expected to work on this 6G. Some of them are ITU, that is the International Telecommunication Union. Then the next generation of mobile network. Then the third generation partnership project, IEEE, ETSI, IETF, NIST, and the fifth generation public-private partnership. Companies working on 6G technology. Many companies are working on the 6G technologies, and some of the leading companies has published white papers also. The companies that are mapping on 6G includes Huawei, LG, Nokia, CTE, Airtel, NTT Docomo, Ericsson, AT&T, Samsung, Apple, and Qualcomm. The research perspective of 6G technology. As the research community is working hard to develop this 6G technology, some of the research includes University of Oulu in Finland had developed a new UAV-based communication system for 6G network, and the University of Southampton has developed a new AI-based algorithm to optimize the performance of 6G network in real time. To reduce the carbon emission, the University of California, Berkeley has developed a new type of solar panel to power up the 6G network, and the Nokia Bell Lab has developed a new 3D networking architecture for 6G network, and one of the major projects is HexaX, which is launched with Ericsson. Competition on 6G technology. Many companies and organizations are investing heavily in the research and development of the 6G. Some of the key players include China, which is in leading position, that is about 40.3%, which is followed by United States, Japan, Europe, South Korea, and India. The market and trends. The global 6G market size was valued at $5.1 billion in 2023, and it is expected to grow at the compound annual growth rate of 34.2%. And several factors impact on the 6G market, such as technological advancement, the emergence of smart cities and IoT, and the rise of metaverse, which shape the development and deployment of the 6G technology. Moving on to the future communication technology. The future communication technology shape how we work, learn things, and how we communicate. Some of the benefits are faster and secure communication, innovative application, efficiency of energy, and economic growth. The future communication technology involves advancement in existing technologies such as beyond 5G, AI integration, IoT and smart devices, augmented reality and virtual reality, satellite internet, advanced video conferencing, healthcare telecommunication. Then the scope for future communication technology. The scope for future communication technology includes a potential in various fields such as telecommunication, healthcare, education, entertainment, transportation, public safety and emergencies, global communication, smart city, and environmental monitoring. Moving on to the conclusion, as a new technologies continue to emerge offering greater benefits, it has a potential to revolutionize the way we live, work and communicate. And technology has introduced new, easier and faster way of communication, and it made easier to bring creative minds and ideas. The technology enhanced security and privacy, and new technologies such as 6G and other advanced future communication network are expected to make the mobile devices even more powerful and versatile, and the future of this communication network is dynamic. These are the references. Thank you.